I would consider these A or even A plus level questions. Okay? So I might feel comfortable doing something like example 6 as a multiple choice, probably not as a written. What will you get on your test as a written? I'm telling you right now, there's going to be cliff at an angle, horizontally from a cliff, and ground at an angle. And then one vector question. Which vector question? Either airplane in a crosswind, boat going across a river, or maybe a change in. Then there'd be a couple multiple choice questions. Says this: a projectile is launched from the ground with an initial velocity of 88 meters per second at an angle of 70 degrees with the horizontal. What is the velocity, magnitude, and direction of the projectile after 4.6 seconds? I think the first thing I'm going to do is dulp, and I'm going to dulp this initial velocity. It says 88 meters per second at 70 degrees. 70 degrees is pretty steep. 88 meters per second at an angle. Did I say angle? This is a job 4. Components. So I'm going to break this up into Vx and Vy initial. And hopefully you've done this enough now that you're getting pretty monotonous at it. I love the fact that Janelle is yawning. This is boring, Mr. Dueck. Yeah, it should be. Should be boring. Hopefully you've done it enough that you're like, oh, really? Piece of cake. So let's go hypotenuse, opposite, adjacent, cosine of 70 equals Vx over 88. I was so lazy I didn't even bother writing the over 88. I started to, and then I just said, oh, for Pete's sakes, put the 88 in front of the cos, because that's where it's going to end up. Vx equals 88 cos 70, 30.0978. Vy is going to be the sine of 70 over, oh, you know what? Let's just put the 88 right there. Oh, and that's Vy initial, because Vy is changing. Vx won't be. 82.693. Am I correct? Okay, got that? Okay. That's not really what they asked, but because they gave me a projectile at an angle, I'm going to go components. Abraham, what do they want me to find?
Velocity and
magnitude and direction. Keep reading. Of
the projectile after 4.6.
Okay, don't write this next bit down. It seems to me that might look like that. Although it could look like that. I don't know if it's on its way up or on its way down. I could guess, but is there a way I could figure out ahead of time whether it's on its way up or on its way down? Katie nodded. How? I could find time. I'm lazy. I'd like to see if I can figure it out without even bothering to find time. So, here's my argument. If it was on its way up, don't write this down, it would look like this. Yes? Is it at an angle? This is a job 4. And don't write this down. I would break it up into, and here's the key, right there. If it's on its way up, what would Vy final be? If it's on its way down, what would Vy final be? I'm going to find Vy final now without drawing anything. And that will tell me, and I don't have to find time. So yours would work, but I'm lazy. So now I'm going to make a little note here. Find Vy final. Y, so we're vertical. What else do I know vertically? I'm not doing a full T-chart. I'm doing an abbreviated one now, because as always, once I give you a strategy, we can modify it for convenience and laziness. What was our no-brainer vertically? What?
for example.
Thank you. Oh, they told me time. Ibrahim, how much time?
4.6.
And since time is a scalar, it can go in either column. Oh, and I know Vy initial. It's going to be 82.693. I can find V final. In fact, I'm going to use our first equation from Physics 11, just Vf equals Vi plus AT, and the Vf is by itself already. Vf equals Vi plus AT. I think I might have said that the other way around there. So, it's going to be, oh, I have this number stored on my calculator conveniently. Plus negative 9.8 times 4.6. I think this is still going to be positive. Hey, it is. So now I'm going to dulp, but now I'm going to dulp that velocity after 4.6 seconds. Let's write this down. 37.613. What did I say? 37.613. So if I dulp this velocity now, I'm going to argue it's going to look like that. It's on the way up. Now I'll write that down. And now I'll say it's on the way up at an angle. Did I say angles? This is a job 4. So I'm going to break it up into horizontal and vertical, where this is Vx and this is Vy final. And I know these. It's going to be 37.619 and it's going to be 0978. And this is the velocity that they're wanting me to find. Yeah.
That's 37.613.
3. Did I write it down wrong? 3, not 9. Thank you. Candy for you. See, the problem is I always have to remember what's on my calculator. I can't keep my calculator on my screen and write at the same time. You guys can just have your calculators next to you. So, yeah. Hey, Sean, how would I find the magnitude? And you know what? If this was a multiple choice question, I might only ask for the magnitude just to save yourself a bit of time. Or I might only ask for the direction and you could skip finding the magnitude and go straight to finding theta. Theta is going to be down here where the vector is originating from. So V is going to be that number squared plus 0978 squared square root. I get a magnitude of 48.2 meters per second at opposite adjacent tan theta equals opposite 37.613 over 30.0978. Shift tan 37.613 over 30.0978. Do you get 51.3 degrees? If you said north of east, Brian, I would accept that, but I'd glare at you because straight up is not north. How did we phrase this last time? Do you remember? Above the horizontal. What's the what's the velocity, magnitude, and direction after 12 seconds? I have a feeling it's probably on its way down, but I'm not sure. Now I still know Vx. Vx was 30.0978. I'm going to find Vy final. Vy initial was 82.693. AY is negative 9.8. And in this case, time is 12 seconds. It's going to be the same equation as before. VF equals VI plus AT. I have a feeling I cooked this so that we'll get a negative answer. 82.693 plus negative 9.8 times 12. Yep, we're on the way down. 34.907. Negative, sorry. Okay. So I'm going to dulp the velocity after 12 seconds, and I'm going to argue it's going to look something like that. This is the velocity they want me to find after 12 seconds. It's going down at an angle. Did I say angle? Okay. Now, little advice for you, my angels. Look up. I've drawn this poorly. Don't go like that. Don't write that down and go like this. We want to use the angle that's below the horizontal. We want to use that one. So I'm going to cleverly put my V underneath that line. And now I can go d d d d d d d. Here's Vx. D d d d d. Here's Vy final. You could have dropped down and gone over and found this theta here, but that's not below the horizontal. That's right of the vertical and below. I don't know. I don't even know how we describe that one. Do I know Vx? Do I know Vy final? Pythagoras? It's going to be 30.0978 squared plus answer button squared. Now, I realized that I have a negative, but what happens when you square a negative? Yeah, so I can be a little casual. If I wrote it here, though, if I wrote in Vy final, I would write it as positive 34.907. Where'd the negative go? It's that down arrow right there. That's where the negative is contained. It's contained in there. Square root. Oh, you get 46.1? I accidentally hit enter again. Whoop, change colors, Mr. Dueck. At opposite adjacent, it's going to be tan theta equals 34. This is where you definitely don't want to put the negative in. All over 30.0978. Should be close-ish to 45 degrees, I bet you. Do we all get 49.2 degrees? Below the horizontal. 49.2, Mr. Dueck. Is that okay, Katie? You made it through? Little Foxtrot comic. So here's Peter writing a test. A projectile is fired from a cannon at a 30-degree angle with the ground from the ground and an initial velocity of 100 meters per second, assuming no air resistance and g equals 10 meters per second squared. We use 9.8. Calculate the time it will spend in the air. You'll notice this is correct. I see components. And then we go a little haywire. It says, time's up, everyone. Please pass your test forwards. Doodlers should not take physics. Shooting for an A for appalling, are we, Mr. Fox? Doodlers should take physics. I disagree with this. I already said you could do number 1. Yes? If you want to try from lesson 6, you can now try number 4, number 5, and number 6. I'm not going to collect those, but if you want to try them as A+ level questions, you can. But really, you're going to get two things. You can work on the ultimate kinematics review, and I'm going to give you a take-home quiz.